that packet for experiment 11, we're going to kind of go back and forth a little bit in it. There's going to be ultimately 3 sections that you guys are going to fill out on your own, and then you can go home. I'll give you an assignment over this that will be due on Monday. Okay, so some of this is going to be review from yesterday's lecture, but I think I'll just kind of quickly go over it. So first off, if I turn over here, this is the whiteboard that we have in room 304. Okay, and we've been talking about molecular compounds, okay, and ionic compounds. We've talked a lot about the differences. And so now we're going to talk about ionic compounds, just focus on ionic compounds. And like this says, you are actually going to write the formula, okay, and the word nomenclature means name it. So you're going to, for these compounds, ionic compounds, you're going to be writing chemical formulas for the compound, and you're going to be naming it. And I think I have an asterisk in my lecture guide for this, maybe, that this topic in my lecture guide says will only really be covered heavily in lab. So this topic is covered in lab, not much in lecture. I will, I feel like I'm getting all serious on you, but so your unit exam, for your Unit 3 exam, is going to have maybe 20-25% this topic. So you want to get this topic under your belt. All right. Okay.
When our unit exam will be?
I do not. It could be as early as 2 weeks from today would be the earliest. It could be. So this is like old hat. We've been talking about electrons, and not all electrons are created equally. Some electrons are valence electrons, okay? And so when we talk about ions, that is important. Valence electrons are in the highest N. Also, you can find valence electrons. Let me grab my periodic table. You can know the number of valence electrons, we said recently. If for the group A elements, you know the number of valence electrons. If you just look, if they're group A, you look at their group numbers. So we have 1 valence electron, 2 valence electrons, 3 valence electrons, all the way to 8 valence electrons. Okay, speaking of 8, atoms want to try to get this complete set of 8 electrons around them, and that's actually why ions are created. That 8 is called a rare gas configuration. Of course, rare gases is the name of this last column right here. So when it comes to ions, we have ions that just have 1 atom. Ions that just have 1 atom. They are called monoatomic ions. I'm missing an O there. Oh my gosh, I just now noticed that. So it should say M-O-N-O, monoatomic ions. Okay, and then today we're going to talk about polyatomic ions. That basically they are a set of atoms that are stuck together floating around with a charge. Polyatomic ions. Okay. But what an ion is basically it has either extra electrons and it's negatively charged, or it's less a few electrons and it's positively charged. Those are 2 types of ions. Okay. So like I was saying, an atom or something, a polyatomic structure that has fewer electrons than it has protons will be positively charged. That's a cation. And if it has extra electrons, okay, it will be negatively charged, and it's an anion. Okay. So, starting with, remember, early on we've been focusing on the jag. We need to kind of remember where the jag is. That jag separates metals from nonmetals. Okay. So starting with the metals in 1A and 2A and 3A, just the metals. Metals have a relatively low electronegativity, so actually that means that they are cool to let go of electrons that are between them and another atom. So metals in 1A, 2A, 3A will lose all of their valence electrons, and they'll form a +1, +2, and +3, respectively. So sometimes what I'll tell students is you can take this whole column, this whole group, and write a +1 up there, because that's what cationic form they form. Okay, you can take this one and put a +2, and then over here, remember the jag actually goes between boron and aluminum, so the metal, aluminum, starting with that going down, it's +3. And then if we turn our attentions to the nonmetals, okay, the nonmetals I usually like to start here with the 7A and then go 6A and 5A nonmetals. They form a -1, a -2, and a -3 respectively. That's kind of what I do, and it looks like this. So
I
the
have a question.
Mhm.
For the +3, so do you not count boron then for those? Then?
Right, boron, yeah, you don't count boron because it's the metals tend to lose electrons and it's a nonmetal. Actually, I think it's maybe metalloid, I don't know. But boron, exactly. So those are this slide and the slide kind of like it with the cations. You can hang your hat on what ion it's going to form. Okay, not so much with the other elements. Okay. So this is a new slide from what we've been talking about. So today you are going to write the formulas for ionic compounds, and then you're going to also name them. So when it comes to writing the formulas, you are going to ultimately make sure that you end up with where's the word neutral? You're going to make sure that it doesn't have a net charge. In other words, it's a neutral, what we say a neutral formula unit. I'll show you an example. So what's table salt? What's the formula for sodium chloride? Yeah, NaCl, exactly. For sodium chloride, you guys would tell me it takes one Na and one Cl. That's awesome. If you find Na on the periodic table, it's 1A. So actually Na is a +1. Okay. If you find Cl on the periodic table, it's 7A, so that's -1. So Cl is -1. And do you see where if you have, and sometimes I'll kind of do it like a little mathematical thing, if we have 1 sodium +1 plus 1 chlorine -1, do you see where if you do that little math, the net charge is 0? So that's kind of what we mean by writing the neutral formula unit. Now, as we get started here, sometimes students will want to put the charge in the formula. Do not put the charge in the formula, okay? Like it's not Na +1, Cl -1, it's NaCl. All right, we'll talk about how you get that. We're going to start with I'm getting ready to turn you loose. I'm kind of excited here. I guess I should be. We're getting ready to do the first part of 3 parts in this lab. And what we're going to do is just take single atoms that are monatomic atoms that are ions. Okay. Now, my favorite way to get a neutral formula unit is to crisscross. Let's do these few slides. Okay, so sodium is a +1. Fluorine is, we said that little dot there is the valence electron around a sodium atom. Okay.
Do you know where this is? It's in the lecture notes. Can you go back a slide?
Oh, this is in the lecture notes.
Yeah.
Okay. Is this on the lecture notes too, or is this in the?
It's not in your, this shows
Okay.
in your lecture notes.
Did it stop right here?
It started right one that we don't and then this, but I mean, we already have this right there, so. Like this is the same slide, but then this is
Oh,
all
I
in
might
it.
skip to what is this by convention. Okay. Thanks, guys. So this one is not in the thing, right?
It's not in our lab, it's in our lecture.
Okay. Yeah, so hang on, guys. I think I'm going to skip to this one. Thank you, guys. Yeah. Great. Come on, come on. My laptop was making funny noises a little bit ago, so. You can do it. All right. There, this one, is that right? Okay. So just like we did with sodium chloride, we don't write the charges, like I was saying. We usually put the positively charged metal cation first, and the anion is last, okay? And then in the third part, we're going to talk about polyatomic ions. An example of a polyatomic ion is like sulfate, nitrate, phosphate, those eights and ites, and okay. If you need more than one, you need to use parentheses. We'll talk about that. I kind of talked about that in the lecture a little bit. Okay. So now, do you guys have this one? No. Then it goes on to. Thank you. Okay. So let's just go on to skip a few slides, and it looks like this.
Yeah, that's in the lecture notes where it has the bi-convention and that.
Okay, good. Okay. So, and I'm going to show you the crisscross method here in a minute, I think. So just hold that thought. But we need to name them too. So NaCl is the neutral, the charges cancel out and it has no charge. But how do you name it? You give it the first name is the name of the metal. And for the first ones we're going to do, it's pretty straightforward. If there's only one form, and I use the word hang your hat. So like, for instance, when I had this out just a minute ago and I said you can hang your hats on, these are all +1, these are all +2, these are +3. You can hang your hat on it. And then over here I said beginning with fluorine and chlorine, bromine, iodine, and acetylene. Those are -1, then we have -2, -3. Okay, but for the metals, if there's only one cationic form, then you just have to do the name. Okay. Now there are 3, and I mentioned this yesterday, there are 3 kind of nested, and actually I have some circled in purple here. There are 3 within the group B elements that always have the same charge, and you just use their name too. And so silver is always a +1, zinc and cadmium are always a +2. So you won't have to use,
Will you have to memorize that?
yeah.
Okay, good one.
Yeah. But what I kind of try to say in lecture is you don't have to memorize, you know, these are +1, you have to have a periodic table and say they're +1, okay? But yeah, you do have to memorize silver's +1, zinc and cadmium are +2. So again, it's like when you name a compound that's an ionic compound, you give it 2 names. It's kind of like people have 2 names. We have a first and last name. And the first name for the ionic compound is just the metal. And if it only has one cationic form, it's just, you don't have to say what cationic form it is. There's Caitlin. I need to call her in.
We could probably yell out the window.
Go on to the next slide because we're so close. So ionic compounds, we're naming them, we're writing the neutral formula, and then we're going to name them. They're going to have a first name and a last name. First name is going to be cation, we kind of talked about that. The last name is going to have to say what the anion is. And for these first parts, we are simply picking one of these nonmetals, a monoatomic anion. So what we need to do basically is to take it and to kind of lop off the last name of the element and replace it with ID. And I almost sound rude because we have ITE coming up, so ID as in dog, IDE, a monoatomic anion. Okay, so is this where? Oh, good. So you guys got this right here, anions. You have this whole thing already filled out. So those are all nonmetals. Those are all nonmetals, and they're kind of taking the name. Let's see, it's like we're on page 11.
It's like a, yeah. It's the very top of it. It's, yeah, it's like halfway through. No, back, I think. Well, maybe not.
Oh, you're close.
Yeah. Yeah.
Okay.
like?
So like you guys told me, so it's sodium chloride, for instance, and of course Cl is chlorine, but you kind of drop off the INE and replace it with the IDE. And this is kind of, so this slide could be helpful for like the last names. Okay. So now let's go ahead and finally take a look at. Thanks for keeping it. Let's take a look at the first part, which actually goes back to. Oops. Okay, good. Oh, all right, thanks. It is on further. So, right here on 1111. Thank you. So page 1111 is the first of three that you guys are going to do. So look at page 1111. And for instance, let's do one together. So I'm looking at C. At C, does it say Al 3 plus I minus 1? Is that right? Okay. So I want you to do, and I'll kind of put it up here. So for 1C, Al plus 3 I minus, right?
No, that's Cl minus.
Oh, thank you. Cl minus. Now notice that this is consistent with what we've been talking about. We said aluminum is a plus 3. We said Cl is a minus 1. In the next column over, what I want you to do in this section is to write the neutral formula. Now, I love this crisscross method. See what you guys think. I think our textbook uses this. Basically, you take whatever the charge of the cation is, and you make it the number of anions you need. Okay, and you take whatever the charge of the anion is, which of course is 1, and you make that how many cations you need. I call it the crisscross method. So if I were to rewrite this, it would look like this. Al, and I need 1. So I'll put it, sometimes students want to put a 1 there. You know, you don't have to. Al1, but you can if you want to. And the number of chlorines I need is 3. I need 3 chlorines. So that actually goes right next to your Al plus 3 and Cl minus 1. And then I need one more piece of information there. You need to name it. So the first name actually would just be aluminum. And what would the last name be? Chloride, yep. Okay, so you'll do that for those. Let's do one at the bottom there. Calcium phosphide. Is that what you guys have for E? Calcium phosphide?
We have magnesium phosphate for E. Oh, 2E, sorry.
Yeah.
Never mind.
Thanks, 2E. Or I don't think it's 2E, but. So for that one, you need 2 things too. Calcium phosphide. Okay. So you need to have a periodic table. I don't have the periodic table memorized. But you'll write Ca, and what charge is Ca? It's 2. It's plus 2. Yep. I know. It's plus 2. And what charge is phosphide? It is -3. Very good. Okay, so if I go ahead and crisscross, maybe this time I'm going to go ahead and write Ca. Do you see that I need 3 Cas? Because that's the number on the charge of the phosphorus. And then how many phosphoruses do I need? 2. It kind of, like I said, crisscrosses like that. And one of the things you need to make sure that don't get these guys to floating. Okay, those are subscripts. They're like H2O. They're like, how many of those do you need? Okay, so I'll turn you loose for a little while, and then we'll kind of take it up a notch for the second part. And I'll be here if you have any questions. If you've had a chance to look at it, all it does is it kind of does something different with the cations. And if you have this sheet, if you can find this sheet in your, it's called Common System Names for Ions Formed from Metals that commonly form two different stable ions. That's not that many.
Oh, it's page right before.
Okay, page right before it?
Right here.
Okay, cool. So what page is that? It's like 1110, thank you. So 1110. So here's the problem. Like if your metal is not 1A, 2A, and it's not 3A, if it's one of these like B elements, metals right here, or if it's kind of, goodness, it could be a metal here or these right here, then it forms different cationic forms. And in its name, you have to say what cation it is. So there's a couple of different ways to do it. We're going to use Roman numerals. So for instance, if it's the Fe+2, okay, actually you can't just use iron as its name. You have to say iron 2, okay. If it's the copper +1, you have to use copper Roman numerals 1 in parentheses. So you have to say its name like that. So let's see, what else do I have here? Okay, so so in part 2, we kind of have a little bit of mixture. If your metal isn't 1A, 2A, and if your metal's not 3A, and if your metal's not one of those three I told you to circle, then you have to use Roman numerals to say what the charge is. So that's just kind of how that works. Okay. So let's take a look at, for example, if you go to part 2, looks like you guys have D and 2D. Is that the, do you guys have Cu +2, S 2-? Okay. So you guys have Cu +2, S 2-, right? And we need to go ahead and make a neutral formula, and we need to name it. Now, I chose this on purpose because what I told you before, if you crisscross, okay, if you crisscross, actually, you would tell me that you need, the number of Cus you need is 2, and the number of S's you need is also 2, if you crisscross. Okay, but I'm telling you one more thing about crisscrossing. This is one pitfall of crisscrossing, that really, if you get two numbers like that and you can reduce it, you need to reduce it. So instead of that, the real formula would be Cus, okay? Because we can take each of the 2's and divide by 2 and get 1's. Does that make sense? That's one pitfall of crisscrossing. Although I think this semester, if you leave it as 2's, I think I could go with that. So let's name that thing. So since copper is like it's a group B element, we'll write the word copper, and we'll have to say in parentheses, using Roman numerals, what its charge is. So it'll be parentheses Roman numeral 2, and of course the last name would be what? For sulfur, it'd be sulfide.
So I have a question.
Uh-huh.
Can't you use the cupric?
Yeah, you can. And then
Okay,
I'll
so
just,
what one do you prefer?
I prefer Roman numerals, but if you're used to using the other ones, I'll just cross-reference. So you can use either. I prefer Roman numerals. They seem easier to me. Any questions about that? And then you should do fine with the bottom of that page too. Let me know if you have any questions. So I'll give you a little bit of time. Now if you don't get all the way done with these, actually I have the answer sheet to give you to take with you. Okay, and the last part we talk about polyatomic ions. Oh, come on. Maybe it needs to go like here. So you have, is this it? Is the next one? What happened? What? Sorry.
Okay, yeah.
This one? I don't have that. Okay, so in your notes, if you find this, the slide before it says, I think I might have mentioned, if you need more than one polyatomic ion, you have to put it in parentheses. I wish this would work. Okay, so let's see. How do I say it? Oh my gosh. Polyatomic ions, these are some examples of polyatomic ions. So if you find in your notes something that kind of looks like this, and you find in your notes something that looks like this, and you mentioned memorizing, so these are the ones you're going to want to memorize. These are polyatomic ions. And I have some thoughts for you on memorizing them. First off, these are these things I'm giving you. You can cut or get somebody to cut them for you and make little flashcards out of them. And the flashcards end up looking kind of like this, where one side is the name and the other side is the formula for the polyatomic ion. So it's a thought. There also is the, I'll show you maybe tomorrow, that Mahjong that I showed you, chemistry Mahjong. It has where you can match the name of the atom or element with the symbol of the element. It also has polyatomic ions, which is kind of fun.
So this packet, these are all things you have to memorize?
Mm-hmm.
Okay.
But in that packet, and I've thought about revising the packet that I gave you, in that packet, some of them are the ones that you already know. Like in that packet, for instance, is sodium. You're like, hey, I know sodium's a +1 because of where it is on the periodic table. So I would cut those and at least just use the polyatomic ions. Okay, so let me kind of help make sense of some of the polyatomic ions. Most of them are negatively charged. Now, what I tell students is actually, if you find this page or this in your notes or whatever, I would find this page, and like at the bottom of my page, I have added these two polyatomic cations. Most of them are negatively charged. There are two positively charged ones. Okay, so ammonium is NH4+. Did you find it? Yes, it exists. There's a bigger one on 11.9. Here. 11.9.
Oh.
Right. So if at the bottom here you write NH4+ ammonium, because all those other ones are negatively charged. And then if you also write Hg2, 2+, mercury 1, that would be great. Let me go ahead and apologize for the mercury 1 polyatomic cation. Okay, this thing right here, the Hg2, 2+, what it is you have two mercury atoms, Hg bonded to an Hg, all running around with a +2 charge. That thing sticks together like glue. It does not come apart. Okay. And as you're looking at that sheet on 11.9, you'll notice that most of them have oxygen. There are a few exceptions. And the exceptions are, oh my goodness gracious. Here are the exceptions that don't have oxygen. So the way this sheet works that I gave you is if you find, for instance, carbon, you're going to find, under carbon, you're going to find this cyanide. Cn-1, it's under carbon. Thiocyanate is also under carbon, SCN-1. Triiodide, I3-1. So when you go to memorize these things, you're going to need to know these polyatomic ions, what atoms go together to make them, what their name is, and what the charge is. Okay. Remember I said that your unit exam is going to be about 20-25% this material. Okay. So sounds like a threat. Sorry. So here's some other hints about the ones that have oxygen. Most of them have oxygen. And it looks like this. If you find like nitrogen or sulfur or phosphorus, something that has oxygen, okay, and there's more than one form, the one that has more oxygen ends in ATE, the one that has less oxygen ends in ITE. I think I've got some examples coming up for you. Goodness. Is this, do you guys have this slide? Okay. Okay, so if you look at sulfur, sulfur combines with oxygen in two ways. You've probably heard of sulfate, but there's also a sulfite. Sulfate is SO4, 2 minus. Sulfite is SO3, 2 minus. Okay. Nitrogen, you've probably heard of nitrate, but there's also nitrite. Now, that's a good example where nitrogen, the two options with oxygen are NO2 minus 1 and NO3 minus 1. So the NO3 minus 1, more oxygen relative to nitrogen, it's nitrate, less oxygen, nitrite. But actually, I was teaching this several years before I finally saw, but they all have the same charge, you know what I'm saying, within that group of, within that element of oxyanions. So, let's see, I have a few more hints. So the halogens, remember we've talked about the periodic table, that 7A right before the rare gases. This column right here, these are called the halogens. They combine with oxygen, actually 4 different forms. And they're all a -1. We have a ClO, a ClO2, a ClO3, a ClO4, all -1. Now right smack dab in the middle are our ites and ates. So ClO2 minus is chlorite, ClO3 minus is chlorate. A little bit, if you're dying of heat loss, if you've lost heat, you're hypothermic. So actually, one less oxygen, we put the hypo prefix now. So hypochlorite is ClO minus 1. A little more oxygen, and we put another prefix for the chlorite. We put perchlorite. So excuse me, perchlorate. Chlorate. So that pattern exists for chlorine, bromine, and iodine. Then I have another hint for you. Within some of the elements, the oxyanions, we start kicking in a hydrogen. Every time you kick in a hydrogen, you have to say it in the name, and it also bumps the negative down 1. So I have some examples coming up. And the examples look like this. If we pick on sulfite, which is SO3, 2 minus, there's a hydrogen sulfite. Some people call it bisulfite. That will work too. And now notice instead of being 2 minus, it's 1 minus. Okay? So those are just hints. We have the sulfate and hydrogen sulfate. Carbonate, hydrogen carbonate. Notice in each one of these cases we have to say the hydrogen and it bumps the negative down 1. And then phosphorus, we have the phosphate, which is PO4 3 minus, and then we put in 1 hydrogen and 2 hydrogens. So hydrogen phosphate is HPO4 2 minus. Dihydrogen phosphate is H2PO4 minus 1. So I hope that helps. Is that it? Okay, so let's take a look at that last section and see what we got. Yeah, I guess it's called part 3 and part 4. That is the granddaddy of them all. So let me pick one on part 3. Let's see. I want to pick one that let's pick I. So for part 3, I, do you guys have BA plus 2, BrO4 minus 1? BA plus 2, so this is I. And specifically it's 3I. BA plus 2, BrO4 minus 1. Okay, are we on the same page? So the two things you need to do are write the neutral formula and then write the name. So if I write the neutral formula, I'm going to crisscross. So the number of bariums I need are 1. So I'm going to put a 1 down there. The number of BrO4s I need are 2. So I'm going to have to put that thing in parentheses and then put a 2 outside. It's just kind of like math.
You don't have to add subscript outside parentheses, do you need parentheses?
What's that?
If it was like the BrO4 was a -2, would you even need the parentheses?
Right, no. If you don't need more than 1, you don't need the parentheses. So let's go ahead and name this thing. Now barium, actually I was thinking barium needed Roman numerals, but do you guys think barium needs Roman numerals? No, barium does not need Roman numerals. Why doesn't it need Roman numerals? Yeah, because it's a 2A metal. It's just a, yep, very good. So what's the name of the BrO4 minus? And this is where you're going to have to memorize it. But for now, you guys have this sheet to look at. BrO4 perbromate, yes. Perbromate. Any questions about that? So let's kind of randomly look at the last part and do an example. So let's see. Let's look at titanium iodate, M. So M on part 4. So this is 4M. Titanium iodite. So this is why you'll hear me enunciate. Okay, so remember, so titanium, and they don't, was there titanium 2, drat. Titanium 2, iodate. Okay, so I need to unpack titanium 2, so that will just be Ti plus 2. And then I need to unpack iodite. So that would be what? IO minus 1. Oops. IO minus 2. Because minus 1 is hypoiodite. Final answer.
Who's IO2 minus 1?
Oops. Iodite, IO2 minus 1. Oh yeah, thanks. Yeah, okay, good. Sorry, well, IO2 minus 1, got it. Yep. Okay, good. So, now I'm ready to crisscross, and if I crisscross, notice that the number of TIs I need is 1. Kind of get that from the charge on the IO2 minus 1. And the number of IO2s I need is 2. And I'm getting that from the charge on the TI. So the fact that I need 2 IO2s means I need to put IO2 in parentheses and a 2 outside. Any questions about that? Okay, so I'll turn you loose, and this is where sometimes I don't make you do the whole thing.